Hi, welcome to session 13 of the grade 6 course. We are back to doing our recaps. So hit the pause button, look up if you need to. Hopefully some of this now we're feeling really confident with. Give it your best shot and press play when you're ready. Okay, here are your answers. You can see I've highlighted the angles question. I'm going to go through that one, make sure that one's gone okay. Otherwise, there's your answers. So just hit pause, check through everything, make sure that you're happy. And then when you're ready, press play and we'll do that angles question. Okay, I'm just going to give myself some space to work in. We'll move this up a little bit. There we go. We don't need to look at that. And we will crack on with this. So your brain should be firing up simultaneous equations because when we look at this, we've got X and Y. Having those two variables means I'm going to need simultaneous equations to help me work out what my X and my Y is. So I know just from that I need to be writing myself a set of simultaneous equations. I've then just got to start thinking, right, where are they coming from? So what am I looking at and what do I know? I'm looking at a diagram with angles. I can see the diagram has parallel lines. I know that angles on parallel lines can be equal. They can be equal if they are corresponding or alternate. So I'm going to be looking for that when I look at this diagram. And I can see exactly that with this angle here and this angle here. They are on parallel lines. They are corresponding. That means that they are equal. If they are equal, I can write that 3x minus 2y is equal to 2x minus y plus 15. I now just need to rearrange that. So I've got the x's and the y's together on one side and the numerical value on the other. So these two x's will go over, their land is minus 3x minus 2x is x. And then this minus y will land as a plus. Minus 2 plus 1 is minus y, and that leaves the 15 on that side. So I've got x minus y equals 15 as my first equation. And let's get it so we can actually see it as well. Okay, the next equation has to be in the diagram somewhere. So I go back to it, I have another look and see what else I can use, my knowledge, what I can see that's going to help me. And it's these two angles side by side here. They are sitting side by side on a straight line. So that tells me that together they add up to equal 180. So that means I can write that 3x minus 2y plus 2x, sorry, not jump down to the bottom one, my mistake. There we go. Plus, try that again, 4x minus 3y plus 25. All of that is equal to 180. Now I just need to get those x's together and those y's together. So 3x plus 4x is 7x. Minus 2 minus 3 is minus 5y. Get that plus 25 over to the numerical side, take it off the 180, and I get 155. So that is my second. Minus 5y equals 155. Okay, I am not good to go, not just yet, because my simultaneous equations, whilst they're written, they are not matching at the front here. So that's my first job. I need to get 7x. So I'm going to times this one by 7. It's going to give me 7x minus 7y equaling 105. Okay, I'm going to keep it in that order rather than write the second one underneath. I'll just bring that one down. The reason that I've done that is because I can see that this is greater than that. So if I do the takeaway this way round, I'll get a positive number. I might just avoid a bit of negative work. It doesn't matter which way round they are, which one's on top, which one's underneath. So I'm choosing that because I think it might be easier. So I've got to do my takeaway, take away the x's, take away the y's, take away the numbers. 7x takes 7x, they've gone. Now I'm at -5 and I've got to minus 7. I've got that double minus, which means I'm going to be adding. That's going to give me 2y. And then your 55, take away the 5 there, well, 155, take away the 105 is 50, which is going to tell me that y is equal to 25. And now I'm just going to substitute back, into this top one. I've got x minus y is 25, so minus 25. Okay, that's equaling 15, so x is equal to 40. So I think once you get into the stage, the point of simultaneous equations, it's just following through the process, nothing really new there. It is the setting up of them, which is what the grade 6 simultaneous equation is all about. Okay, right, now we've done with the recap, we are going to move into indices. Now, there is assumed knowledge. You're here doing the grade 6, so it's assumed that your basics with indices is secure. Now, we're not going to just literally rush away from it. I've put all the information into this box that you should know already, and I've just done you 6 little questions to practice, just so you can check in and make sure you are comfortable. The grade 6 work, and some teachers will argue it's grade 7, some will argue it's grade 8. It doesn't really matter where it is. It's in the grade 6 course because it's accessible. It's definitely going to be in your GCSE. We want you to get these marks. It's better fitted in here than it is anywhere else. So these are the rules that you should know. Oh, and I can see an error. That's not very good, is it? Okay, let's pop that in correctly. There we go. Okay. When you are timesing the same base, you add the powers. So that's the first one. When you are timesing, you add the powers. When you are dividing, you take the powers. When you've got a power to a power, you times them. Okay. When you have got a negative power, you do something called the reciprocal. Now, if that is new or unfamiliar for whatever reason, I am going to talk about this one a little bit, so don't panic too much there. And you should also know that anything raised to the power of 0 is equal to 1. Okay, so what I want you to do is hit that pause, have a go at those questions. They all require the use of one or more of those in the box, and it just gives you a chance, like I say, to check in and make sure that you are comfortable here before we move on. So hit play when you're ready. All right, let's have a quick look. So 2 times 5 is 10. I don't have any additional E's or F's, so they literally just get squished in. You need to remember that a single letter has an invisible 1. And then it's a times question. They've all got the same base, D, so they just all get added together, and we end up with D to the 12. With a question like this, where we've got quite a lot going on, literally do it step by step. I'm going to do my number work, then I will do my A work, and then I will do my B work, okay? So 32 divided by 8 is 4. A to the 4 divided by A to the negative 2. It's a divide, so I have to take 4 minus -2 creates that positive. So it's going to be A to the 6. And then B, remember, we've got an invisible 1 here. So -3 minus 1 is -4. Okay, so if we got that right, well done. Again, we need to be mindful. There's a lot happening here, so we've just got to do it in steps. So let's first of all get this numerator tidied up. And again, we're going to do the numbers first and then any indice work that's there. So 6 times 5 is 30. I don't have any other P's. So we've got P9 and then we've got Q5 all over the 2P6. And then to finish that off, 30 divided by 2 is 15. I've got P to the 9 divided by P to the 6. So 9 takes 6 is 3. So that's going to be P to the 3. And there's nothing to do with the Q's. So they stay the same. Okay, so let's just make that a little bit smaller so it's not in the way. And then we look at this one. Now, a really common error happens with this. Generally, students are really good with the letter work, with the algebra work, but they forget what goes on here. So some students won't do anything at all and they'll just keep it as 3. Some students will do 3 times 4 and make it 12. But actually, this is 3 to the power of 4. And 3 to the power of 4 is obviously 3 times 3 times 3 times 3, which is equal to 81. The heavens have opened. I don't know if you can hear the rain over whether my mic's picking it up. Very loud, very loud. Okay, the P to the power of 2 raised to the power of 4, you multiply. So we're going to end up with P to the 8, and then R 3 times 4 is 12. Okay, so hopefully you have got those okay. This one, you know, may be a little bit trickier. A lot of people want to put a negative in their answer because of the negative power. I'm going to explain why that doesn't happen in a moment. The answer to this is a reciprocal where we say we've got the 1 over 3, the power stays with the 3, and then I do the maths that I can see, which is 1 and 3 squared, 9. So if you've got a 9th, again, really, really well done. For anyone that's not sure about the negatives, like I say, I've got a quick explanation as to why it isn't negative, which is the default error that most people will make. So we really want to explain why it isn't, and actually explain why it becomes a fraction. So take a look at this. Okay, we'll clean this up and do it here. So we're going to use the base 2 because it's really good at demonstrating this really clearly. So if I gave you 2 to the power of 3, you know that means 2 times 2 times 2, which is 8. You've then got 2 to the power of 2, and 2 times 2 is 4. 2 to the power of 1 is 2. 2 to the power of 0 is 1, because anything to the power 0 is 1. Now let's look at what's actually happening before we do the next one. The powers are decreasing, which means the next power has to be 2 to the minus 1 if we're going to follow the pattern. So let's write that in. And then let's look at the pattern of these numbers. 8 went to 4, 4 went to 2, 2 went to 1. So these have been halving every time. So if it's going to follow the pattern, it's got to half. And 2 to the minus 2, if it's going to follow the pattern, a half of a half is a quarter. And this is why it doesn't become negative. It only becomes smaller. Okay. Now I could also see this half as being 2 to the power of 1. 2 to the power of 1 is 2. I could see a quarter as 1 over 2 to the 2, because 2 to the power of 2 is 4. So because there's a pattern, you can lose the step that you need to take. So if I had something like 5 to the minus 2, I need to know that whilst that becomes the reciprocal, that power must go with it, because actually the answer is that. Okay, so when we get a negative power, we get numbers that are smaller than 1. We go into fractions. The fractions are always reciprocals, and the powers go with the base number in the denominator. And that's it. That's negative powers for you. So why don't you have a go with a couple before we go into our fractions and explain those? So what if I gave you 8 to the minus 2? Press play when you're ready. So we take the reciprocal, take the power with the 8, and it's 1/64. Okay, let's do another one. Let's do 2 to the minus 4. Press play when you're ready. Okay, so I'm going to take my reciprocal, take the 4 with it, and then 2 times 2 times 2 times 2 is 1/16. Now, what about going back the other way? What if I gave you a fraction? So let's say I give you a 9th, and I say I want you to write that as a power of 3. Let's say we'll do it like that. What does n equal? Okay, so what we should be doing is we should be really staying in the fraction to start off with and thinking, right, how do I write 9 as a power of 3? That would be 3 squared. And then to get rid of the fraction, I need to change it to a negative power. So n is equal to -2. So it's really how your brain processes it that's going to get this the best. I could be explaining in a way that sounds more complicated than it is. My brain doesn't always follow an easy pathway sometimes, okay? So it's really important that you don't see this as anything other than taking it backwards, all right? So let's do another one. Let's do that one. What would n equal for that one? Okay, so you should hopefully have worked out that 10 to the power of 3 is 1,000. So it's 10 to the -3 as a negative power. Okay. Right. I could give you a question that's worded like this. Write with a positive power and give you the question 4 to the 3 to the -2. And that's just combining 2. Hopefully you've had a chance to do it. This is combining 2. So you should have used your power rule and multiplied to get you 4 to the -6. Now that obviously is a negative power, not a positive power. So we take the reciprocal of the 4 and pop our 6 there. And we don't need to do 4 times 4 times 4 because it's asked us to write it with a positive power, okay? The kind of next level up. So we do indices again in grade 7, where we look at equations and changing the base. But just to give you a little hint of what that could be, I could have said something like write as base 2. 4 is a number that could come from base 2. Yeah, 4 could come from 2 squared. So what I could do is, instead of writing 4 here, I could write 2 squared, still to the power 6. And then I use my power rule and end up with 2 to the 12. And that would be taking a number that was a base and rewriting it into another base, but keeping it equivalent, keeping it the same value. Like I said, that's something that we delve into in a lot more detail in grade 7, not really here. But I think it's really nice when you're doing indices to just see some of the differences and some of the ways that they can just problem solve and make you apply more to something that feels like it doesn't do anymore when it does. Okay, so those are your negative indices, changing between negative and positives, fractions being the main thing that's going on there. Now we're going to be looking at something called fractional indices, and they are exactly what they sound like. So they are, again, a base number. So let's have a look at an example. Let's have base 25. And we literally have an indice that's a fraction. Okay, now I am going to tell you that the solution to this is to square root the 25, and that is the answer. So the rule is that you root the denominator. So that's the starting of the rule, if you like. The denominator is always the number you take the root of, okay? But I'd like to try and explain why. I think if you've got some understanding behind why, sometimes makes it a bit easier to remember it long term. So I'm going to try and do this as best I can. So I'm going to give us a different number, so it's just not quite as big. So let's take 5. If I raise 5 to the power half and I times it by 5 to the power half, and I use my times rule, which is add the powers, then I would end up with 5 to the 1. A half plus a half is 1. 5 to the 1 is equal to 5. Okay, so I have a fact that I've just written down, that anything raised to the half multiplied by itself, so a half times by a half, is going to give me power 1, going to give me the same base. Okay. We also have this fact. The square root of 5 times by the square root of 5. That is the same as saying the square root of 5 times 5, which is 25, which equals 5. You could look at it like this. Square root of 5 times square root of 5 could be written as square root of 5 squared. Yeah, square root of 5 times by itself. Because the root and the power are the inverse of each other, they just cancel each other out, leaving me 5. So I have these two facts. I have 5 to the power of half times 5 to the half equaling 5. And I have root 5 times a root 5 equaling 5. So it follows that 5 to a half is the same as root 5. Okay, let's move that up a little bit. So that's how the fraction kind of works. And I hope that gives you some background and an idea of why it's doing what it's doing. So what if I gave you a power that was a third? The denominator is not 2 anymore. 2 gives me square root. What does 3 give me? And hopefully we know that 3 is going to give me a cubed root. So what would a power quarter give me? That would be a 4th root, and so on. The denominator of the fraction is always a root, and the degree of root that you're going to do depends on the denominator. A 2 is a square root, a 3 is a cube root, and so on. Okay, so let's practice a couple of these. See it in action. So if I gave you, let's just move that down. If I gave you 100 to a half, what would you do? Okay, you should be pausing and hitting play. A half is the same as a square root. And the square root of 100 is 10. Okay. 64 to the half. Okay. That is going to give us a square root of 64, which is going to give us 8. Okay. Now, I am going to add a little bit here, all right? So I hope I don't overly confuse things. The square root of 100 could be made by doing 10 times 10. 10 times 10 is 100, so the square root of 100 is 10. Sorry, I went over the top of my 1. But minus 10 times minus 10 is also 100. So how do I know whether it was a positive 10 or a negative 10 being multiplied by itself? And the answer is I don't. There's no context in the question to say, I don't know, it's length, which can't be negative. So there's no context, which means my answer could be plus or minus 10, or plus or minus 8. So if we can remember that, that's brilliant. If we can't, seriously, not the end of the world at this stage. Much more important that we're learning how to do fractional powers than we are worrying about pluses and minuses. But it's important that we know about it and try and use it where we can. All right, let's try a different question. So we've got 27 to a third. Pause and hit play when you're ready. Okay, so this is going to be my cubed root of 27. Okay, a number multiplied by itself 3 times. The answer to that is 3. Okay, 3 times 3 times 3 is 27. So the cube root of 27 is 3. Okay, now this one is not plus or minus. It's because it's an odd number of times that we're multiplying rather than an even. Because if you think minus 3 times minus 3, whoops, that is going to give me positive 9. But when I times it by minus 3, I end up with that minus 27, and I can't root a negative. So that's impossible. That's an error. So that's not happening. So I can't put plus and minus on that particular answer. So you can see what I mean when I said it can get a little bit complicated. I always think about odd and even. Okay, so if I've got an odd root, it's got to be positive. It's got to be positive only. But if I've got an even, like this is a 2 root, although we don't show the 2, even means it can be both. Okay, let's have a clean up and do another question. Let's do 32 to the 5th. Okay, 32 to the 5th. So this is going to be the 5th root of 32. So a number multiplied by itself 5 times. It's probably going to be a pretty small number. It is. It's 2. Okay. And that would be your answer there. Okay. Let's look at a different one. I'm going to stick with 32. But this time I'm going to give you this, which is slightly different. The numerator of my fraction has some value now. It's not just 1, which all the other questions have been. So what do we do with this type of question? Now, if you want to have a go, feel free. If you want to just listen and check in with that, then obviously that's absolutely fine. So I am going to proceed with what I know. My current knowledge is that fifth root of 32 is going to give me 2. So my new base is 2. The 5 has been used and the 3 is still a power in its own right. So I hope that makes sense. That's how I see it. Do the root, and then the power that's left is an integer because I've got rid of the denominator. So the numerator now becomes a power of its own right on the result of the root step. So 2 cubed is 8. And this is why we tend to not worry too much about the pluses and the minuses, because actually it's more common that you're going to get a fraction with a numerator as well. Okay, so let's do one. We're going to do 16 3/2. Pause and press play when you are ready. Okay. So we are going to square root the 16, which is going to give me 4. And then the numerator becomes the power, and 4 times 4 times 4 is 64. And if you got that right, really well done. Okay, one more. What are you going to do with this one? 27 to the minus 2/3. Hit pause and press play when you're ready. Okay, we kind of got everything happening in this one, haven't we? I'm going to ignore the negative fact until the very end, okay? What I'm going to do is just go through the process in the order that I've been doing it in, because it is the easiest way to approach it. So the first thing that I am going to do is I'm going to cube root 27, which will give me 3. I've then still got the minus and I've still got the 2. I haven't done anything with those, and it creates 3 to the negative 2. Now I can just go into my negative rules and what I understand there. So that will become 1 with 3/2, which will become 1/9. And if you got that right, just really well done. It's just having that confidence, isn't it, to go through each step carefully and put that trust in the result, doing the next step on it. All right, I'm not going to do any more with you. I have written you a selection of questions. We'll get them so we can see them all. There we go. I've written you a selection of questions based around everything that we've done. You'll do the normal, sort of do a couple, check your answers, rewind. You know the score now. And I will see you next session. Well done today.